Hi everybody, welcome back to section 1.2. We talked about graphs of functions, and last time we chatted we talked about graphs have some types of symmetry, which we call even, which was across the y-axis. And that was, again, remember you plugged in a negative x into your function, and if you got the exact same thing back out, he was called even. The other one we learned was called odd, and odd was across the origin. Both start with an O, so it's easy to remember. And that was when you plugged in negative x, and then you got the complete opposite of the original function. Okay, so we can look at that. We looked at great notes here and great steps, but the other thing I want to look at is how can we look at a graph and just know when is it literally going up and when is it going down? And the fact that it's increasing and decreasing is kind of simple to look at on a graph, but when we get into, say, calculus classes, we need to know increasing and decreasing for very important problems. So for right now, we're just noticing it. We're going to write down where we see it, and you'll see it more next year in calculus when it becomes very, very important. So literally, here's what we're doing. You're going to look at a graph here, friends, and just say, well, as we move left to right, and it's very important that we move from the left to the right, where is my graph literally increasing, which means going up or rising? Where is my graph decreasing or falling? Or where is it not doing either one? We just call it constant, just staying flat. Okay? Now to do that, you're looking to see where it's increasing. So that means your y values are getting more positive. Or decreasing, where your y values are falling. Or just constant, where your y values aren't really changing at all. So you're looking, your eyes are looking at the y values. But here's where it's kind of tricky. Your answers are going to be x values. You're going to give me the interval, the x interval, where the y values are changing, okay? So you look at the y values when it's going up or down or constant, but you tell me where along the x-axis is that happening. Okay, for example, let's take our first one that we see up here. Now, try to just imagine this being made up of little branches where different things are happening. For example, again, if I just work left to right, we have this branch. We have this branch. We have this branch. And then we seem to end with this branch. And each branch seems to be doing something different. So let's make a little list here off to the side. Where am I increasing? Where am I decreasing? And where am I staying constant? Okay, so like I said before, you're going to look at the y values to see where it's going up, increasing, down, decreasing, or constant, flat, but you're going to tell me the x values where it happens. So let's just work left to right. On this first branch here in yellow that we saw, what is the graph doing? Is it going up, down, or flat? If you see, it is up, it is rising, it is increasing. Okay, so now, if it's increasing, let's tell where the x values are, where it's happening. So it's really happening from, it looks like maybe this x value, and it stops at this x value. Okay, that's sort of the area or the walls or boundary where the y values are increasing. So you're going to tell me the x values. It looks like these big boxes are like halves. So this is negative a half, this is negative 1. So I would think this is probably about, maybe about negative 0.75 maybe. And where does it stop going up? And it stops increasing the end of the yellow branch at negative a half or negative 0.5. Now before, when we talked about domain and range, we would use brackets and parentheses, but here for increasing and decreasing, guys, parentheses are absolutely fine everywhere. It's okay. You don't have to worry about brackets here. All right, that one's done. Now how about the next one, the purple one here? What are the y values doing? And it looks like, if I see it, it almost looks like a slide going down. But remember, you are moving left to right. If I was moving right to left, can you see that that purple branch is actually going up? So you'd actually get the opposite answer. So it's really important that you're moving left to right on these, friends. Okay, so this is going down. So tell me the x values where it's happening. I see I start going down here, and I feel like I end going down about here. So I'll put this under the decreasing column here. I'd say about negative, oops, put a negative there, 0.5, negative a half, and it stops going down right about 0. Okay, that's done. Remember, these are x values where the graph is going up, down, or constant. The next branch, the blue branch, looks like, again, from left to right, I'm going up, so I'm going to put that in the increasing column. Looks like it starts going up here, stops going up here. So I'll say under increasing, it goes from 0 x to positive 0.5 x. Okay, these are all x's. And the last branch that we see here off to the side is falling or decreasing. So let's figure out where is it decreasing. From here, it starts decreasing and it stops decreasing, looks like right about there. So I'll put from about 0.5. Stops decreasing, looks about 0.75 or so. And that's it. Anything in the constant column? No. There was nothing that was really, really flat here, so we didn't have any. Good. How did that go? Let's try another one. Okay, on this problem down here, got a couple good questions here. Can you first find where is it increasing? Tell me the x intervals. Can you find out where is it decreasing? X intervals. Constant. And then special one, can you find for me domain and range? And then if you remember from the last section, the zeros of a function. All right, feel free to pause, try it on your own, and then check back with me and see how you did. Okay, friends, let me mark up my graph here so I can see. Looks like this first part here, this little first branch, look, it's flat, and it looks like it goes down, and then flat, and then goes up, and then goes down. Okay, so I can break that into sort of the flats are constant, the downs are decreasing, the ups are increasing. But one thing I want you to notice here is look at the ends of the graph. Do you notice that the far left ends at a dot, but the far right one ends with an arrow? So maybe that's going to sort of affect our answers here. All right, let's take it apart. So some people love to just go literally, number 1, let's find every place where it goes up, number 2, and number 3. Or if you want to, you can just go, again, left to right. Take an interval and fill it in whichever column you see needs the answer. I'm going to try it that way just to see, and you try either way. So I see that the first thing that happens here is it's constant. So now it's flat, so what x values is that happening? It's happening from here to here. So that's from -4 to -3. Those x values is where it's constant. Okay, that one's done. Let's take the next branch. The next branch seems like it's going down, so I'll put my answer in the decreasing answer here. So that seems to be happening from, if you see the x values, -3 to 0. X equals 0 is where it stops decreasing. It's really tempting to put maybe -1 here, but careful, you're looking at the y values if you do that. Remember, our answers are only x values, so don't put the y values. All right, the next branch seems like, again, it's flat, so I'll put my answer under the constant column. And that would be from x equals to x equals. It's flat. Next part goes up. So I'll put this under the increasing. It's our first place where it's increasing from x equals to x equals. And finally, where is it decreasing at the end, going down there? So I'll put that in the decreasing answer. That is from x equals to x equals. Now, here's a tricky thing, right? As I go from left to right, do you notice that my graph is going down, right? It's decreasing. So it's really tempting to say, oh, from 2 to, well, it's going down. So I'm going to put negative infinity, Mr. Brown, because that's down. It's going down. But remember, if you say the word down, you're actually telling me y values, right? Because y is up and down. You need to tell me the x values. So don't say from 2 to negative infinity, from x values. So how far x does he go as he's going down? And it's forever. So I'm going to say it's going to go from 2 to all the way to the right, infinity. Good. That's number 1, 2, and 3. Hopefully that matches your answers. Now let's figure out domain and range. Good. Some old questions here. So domain, let's see. I think that's the x's, right? So I need to figure out how far left does he go and how far right does he go. And then for range, we're going to talk about how low, how down, and up. Okay, so for domain looks like I go from x equals here to, well, ooh, that arrow over here. So it's like he's going to go on forever. This is where we're going to need brackets and parentheses, friends. So my domain here, well, my domain is a blue word, so I'll put my answer in blue for you folks. Let's see, the farthest left he goes looks like -2, and the farthest right he goes, because the arrow is in fin. Remember, infinity will always take parentheses, but since there is a solid dot here up here on the graph, if you see it, I will put a bracket there, because it does touch -2. All right, there's domain. Range. Okay, that's all about how high up he goes and how low he goes. All right, let's do the lowest. Let's see, the lowest he goes low here, but again, because of my arrow, you can imagine he's going to go on forever down. So he's going to go all the way down to negative infinity. Now, how far up does he go before he stops? It looks like he doesn't go any further than here. This is sort of his ceiling. And he goes no farther. And that's at y equals 3. So the highest he goes is 3, and he is touching it, so I'll put a square bracket on there. And parentheses is always needed for infinity. All right, there's domain and range. Last part, friends, is the zeros. And remember, in your brain, whenever you hear the word zeros, you think x-intercepts or roots or solutions. But I think x-intercepts are the best. Okay, so where am I crossing the x-axis? Looks like about here. 1, 2, and 3. So give me those x values. How about x equals, let's see, the farthest left one looks like maybe negative a half, negative 0.5. And also crosses at, looks like 1.5. So I'll put 3 over 2, that's 1.5. And looks like 1, 2, how about x equals 3? So you can just list those x values that are the zeros of the graph. All right, good job. I'm going to give you one more to try for good practice. Here's your last one. Here's your function. Can you tell me where is it increasing, decreasing, constant? Let's go all the way. Let's do domain and range. Okay, so tell me again. Tell me increasing. Tell me decreasing. Tell me constant, if there's any constants. Tell me domain, range, and just enough room. I'll put zeros over here, guys. All right, you want to pause the video, try it on your own, and check on back. Okay, my friends, let's check. So let's check. I'm going to do it now the other way that I did on the previous page. On the previous page, I just went left to right on my graph, and for every change, I just put it in whichever column it fit. This time, I'm going to actually just do all the increasings, all the decreasings, and all the constants in order. So let's see. Where is it increasing? Well, from here all the way up to here, that's an increasing. My y's are going up, but you're going to tell me the x values. That's from x equals to x equals. Again, notice I'm using parentheses because we don't have to use brackets for increasing, decreasing, constant. Okay, is there any other place on my graph I'm scanning left to right where I'm going up? Ooh, I found one. All right, so my answer here would be x equals to x equals. Okay, and the others? Ooh, you know what? Well, I keep going. It keeps going. So look what I could do here, guys. I can keep going and say, well, it also increases from 3 to 5, x values. Or if you wanted to just combine these two and say it just overall increases from 0 to 5, that's also legal. Either of these two answers are fine, folks. It's up to you. Because really, from 0 to 3 it increases, and then it keeps going. So you can make it just one long interval if you want. Okay, that's my increasings. Now let me go back to my graph. Let's see, where is this thing going down? Let's see, the first time I see left to right that's going down would be from here to here. But remember, put x values, not y's. So from negative 3x to 0x, that's where it's decreasing. Don't use the y values. Okay, so I travel along the graph. Next place where it's going down is over here on the end, the last little branch here. And that is x equals to x equals. Great. Well, we used up all of our branches, so unfortunately the poor constant guy, he doesn't get involved in the party. So sad, but he'll get over it though. All right, domain and range. Now let's check and see. Domain and range is left and right. How far left does he go? And how far right does he go? Looks like he starts way over at negative 5, and he ends way over here at 7. And there's no open circles. They are dots. I'll double check. I'll erase my work. Yep, there's a dot. And there's a dot. So I'm going to put a square bracket and a square bracket. Because he does touch negative 5, he does touch 7. For range, friends, let's see, how low does he go? And how high does he go? He goes up here, but ooh, go over here. He's actually going even higher. That's my highest spot. So how about the lowest on the range is, sorry for crossing it out, is negative 2. And how high does he go? He goes all the way up to y equals 4. Y equals 4. And he is touching, so I'll use square brackets. And then zeros. Where am I crossing the x-axis? Looks like here and here. And then I do touch it right over here, so that counts as a 0. So I'll say my zeros would be at x equals, that looks like maybe, what would you say? Maybe a negative a half? Does that sound okay? And then maybe x equals 3. And then way at the end, x equals 7. So there you go, friends. That's how you look at a graph and figure out where is it increasing and decreasing or staying constant, and a good sort of review on domain, range, and zeros. Great work today, everybody. See you next time.